So guys, let's start solving this problem in Java. The algorithm that we have created here. So we are going to implement the same in Java. So right now I'm in my IntelliJ in the presentation mode. Let me first of all copy this method, exactly same as given in Coding Ninja. We'll mark it as private and final. Okay. So here, let's revise this again, that we will start from 0 to n, that is n is 5, for example, and we'll keep on calculating dp1, dp2, dp3. And the algorithm that we have derived in our previous video is that we'll start from index 1 to 5 and take the dp of that index minus whatever is left is the price of price index. Like for 5, start with 1 and 4 and 2 and 3 and on. So let's start implementing the same. So first of all, I will create our dp array, which would be n plus 1. Right. For 5, we start from 0, so it's total 6. That's why we have taken n plus 1. Now let's iterate through it. dp0 we don't need to calculate because in Java by default this array would be only containing 0 for all the indices. So we don't need to do anything for this. Let's start with dp1. So dp1 is price 1, that is index of 0, plus dp of 0. 1 minus 1 is 0. So I'll start with 1 equal to n, because we have to go from 1 to 5. From 1 to 5. And let's, because we have to find the maximum of all the combinations possible. So that's why we need to iterate through it. But before that, let me store this value by using the int.max. So integer.minimum value. This is I'm doing just so that we just initialize with the minimum value possible, and then we will try to iterate and find the maximum value for all the combinations possible. So it means that I will start with, again, I will use a for loop starting from 0 till I, right? Because say if I'm at 1, start from index I is 1. This is what it denotes 1, index here, price of 1, and then we start for j, it's from 0 to 1, for example. So it's like just 0. Similarly for dp2, it would be price of 1 plus dp of 1. So we start from dp of 0. So yeah, and let me code it first, so it would be very evident that what I'm doing here. So it would be max value of math.max. That's why we have initialized it as a minimum value, because anyway, the first number that will be encountered, that would be definitely bigger than the minimum value. That's why we initialize with the lowest value possible, so that we update it at least with the index of the price index that we have found here. So price of j plus dp of I minus j, and because in Java the index starts from 0, so I have to do additional minus 1. So that's it about it. And then finally, because we are iterating through for all the indices from j to I, and we have found that maximum value based on math.max method. So the dp of I would be final, the max value that we have found for all the combinations possible. And then we just return dp of n, which is 5 in our case. Let's go through it again. So for example, I start with. So we keep on continuing this for this whole array, and then we return the final maximum value as we have found here by using the same formula, the same approach as we have derived here. So we take from index, say from 1 to n in our outer loop, from I is equal to 1 to n. And for each of the values that we have already computed from 0 to I, we do this. We find the maximum value of all the combinations possible using price of j plus dp of I minus j minus 1, because minus 1 is included here to avoid the because in Java the indices starts from 0, so that's why we have to put minus 1 here. But the basic idea of algorithm is this only that we have derived in our previous video. So this is all about it. Now let's see the sample input using this Coding Ninja. And first of all, before submitting the problem here, let's try to test first. So here in this Coding Ninja platform, they have got this input like this, that the first line would be given as 2, which is the number of test cases possible. So this is the first test case where the rod is given of length 5, and this is the cost of each length. Like the cost of 1 is 2, length of 5 is length of 2 is 5, length of 3 is 7, and all. And the output is given as 12 for this first test case. And similarly for the second test case, if the rod is of length 8 with all the prices of the lengths given here, and the output is 24. So let's try to test this by using this sample input. So I'll write it here. Yeah, let's use the scanner class here in Java to read the input. Okay, scanner. I'm using try for resources so that we don't need to explicitly close it. Okay. Now I need to check first of all the first. Let me copy this first here. So the sample input, I will just copy it here. Okay. So this first line is the number of test cases here, which I'm storing in T. So it would be integer s dot next line. I need to convert this, so integer this. Okay. So here we capture this two here in T, and then let's iterate through all the test cases and less than T. Okay. In the next line, we first of all check for the test case, which is 5, which is the length of the rod. So I will mark it as n, and again do the same thing. Guys, you can also use s dot next int, but I think this is better. I mean, whatever is fine. I will treat all this input as a string and then convert it into whatever way I want. So I will use price. Now this is the price input line for the first test case. And I will use s dot next line dot split on space, right? This will actually store this input list in an array separated by the space. Okay. Now, because we did it into an integer format here, this one, so that's why let's parse it back into an int, this price, and first of all, let me create this price input line dot length. Now let's initialize this all with the value given, which is to again price dot length. Okay. Type j would be just integer dot percent again. And j. Right. So here we have just passed this input 5 in n, and the price input as an array here. Now we just need to call this method which we have just created, cut dot, and I will pass price and n. So this will iterate 2 times because the number of test cases is 2, and then we will run this. So yeah, that's about it. Let's run this by taking the same example as given here. Okay, so we are given the output here, output box here. So let's do it one by one. So let me just copy this first test case. So the answer is 12 for the first test case. This is matching. Now let me try for the second test case. It's 24. This is also matching now. Okay, so our test cases are matching with the given sample inputs. Let me copy this code. Here now we have tested the sample input case, and just run it first. Okay, the test cases are matching. Now let me submit this code. Okay, it's all working. Answer is correct. So guys, that's about this problem. We have implemented this using the approach that we derived here. So for any dynamic programming problem, we need to start as a bottom up. I mean, we just break it down into like sub problems, starting from the very base case, and then we keep on moving to the next level cases. And the basic idea is to reuse the value which we have already computed. For example, for DP3, we use the reuse for whatever we have calculated for DP2, 1, and 0. And then we try to derive an algorithm which is common, and once we have the final algorithm ready and which is giving me the correct solution, then we just implemented the same in Java, and this is all working. So let's check for the space and time complexity here. I think the time complexity would be because we are using 2 for loops here, so it should be O of n square, because we are using 2 for loops and we are iterating through each of them. And similarly for the space complexity, it would be we are just using this DP array of the single dimension array, so it should be O of n. So guys, that's it about our 6th problem, rod cutting problem that we just solved. In the next video, we will solve our 7th problem in this tutorial series, which is a very, very famous knapsack problem. This is considered like one of the very, very common, which has got a lot of applications. So see you in the next video.